Hi and welcome to Gaffy's Grinds. In today's video, we're going to do a question walkthrough of a titration question. Now, normally in a titration question, it comes up on the exam paper, it's question 1, and it'll always have a calculation in it. Some students get afraid or intimidated by this calculation, but there's really no need to. The maths involved is fairly simple. It's just usually multiplication, division, subtraction, and addition. The only thing is that you have to develop a way of thinking through the question, the steps involved. You have to apply some logic, and that really just comes with practicing a number of these questions. There's lots of questions of this style done on my channel. If you feel free to look through and find some other ones, but today we're going to treat this as if people are beginners. All right, so let's look at it here. It's question 22 on this booklet here. It says vinegar contains ethanolic acid. So there's our acid. So this is probably going to be an acid-based titration then, okay, if we're talking about an acid, so ethanolic acid. Ethanolic acid is a weak acid, so we're given information about that acid. It's a weak acid. Might be important later, it might not. Okay, so I'm going to assume that you've studied acids before you're taking on this question, and you should then, this is a simple recall question, this part A. So what I want to get you to do is I'm going to get you to pause the video, and I'm going to get you to go ahead and write down an answer to A. Which ion is present in all aqueous solutions of acids? In other words, what do all acids have in common? What makes them acids? All right, so pause the video and write the answer down to that now, please. All right, the answer to this that you should have had is hydrogen ions, okay? So all acids have produce hydrogen ions in aqueous solution. And this is one of the definitions of an acid. What is an acid? An acid is a substance that associates to produce hydrogen ions, or some might call it H plus ions, which is also fine here. All right, so that simple recall question out of the way, what we're going to move on to now is discussing the calculation part. And what I want you to do is I want you to pause the video now and read through the text in B and try and make sense of it. Pause the video and read through that now. All right, so hopefully you read through it. You've read through it carefully. Let's go through it and see, did you notice some of the things that I've noticed? So I'm going to talk you through my thought process here. It says pure vinegar contains ethanolic acid with a medium-high concentration. Okay, so that's the same acid that they were talking about up here. When used neat in a titration, it neutralizes bases very quickly, given very small titration values. So somewhere between 1 and 5 centimeters cubed. Now, it gives information after this. It says small titration values are less accurate. So we don't want to use neat vinegar because the reaction, the titration is over too quickly, and those small values are not accurate. Oh, no, there's too much room for error. If you have a titration value of 1.5 centimeters cubed, and you're 0.1 centimeter cubed out when you're reading it, well, that's quite a big percentage of the 1.5. That's quite a big error. Whereas if you have a titration value of 25 centimeters cubed and you're 0.1 centimeter cubed out when you're reading it, well, that's a much smaller percentage of the whole volume that was added. It's a smaller error. Anyway, let's keep going. Because of this, we usually dilute the vinegar before titrating. Okay, now I think we're about to get to some important stuff. It says a student took 25 centimeters cubed sample of vinegar and diluted it to 250 centimeters cubed with water. Okay, so 25 of the neat vinegar to 250 of diluted vinegar. Okay, hopefully you can see how those numbers work. 25 to 250 means it's been diluted 10 times. This is what we call a 1 in 10 dilution. Okay, so 1 of the concentrated vinegar diluted 10 times. Okay, that's probably going to be important later on. So I've made a note of it here at the side. We've got a 1 in 10 dilution. 25 in 250. Okay, that's where those numbers come from. All right, let's keep going. 25 centimeter cubed of this vinegar then, I presume they mean this diluted vinegar, was then neutralized by 30.5 centimeters cubed. Okay, so let's keep these together. 25 centimeters cubed is for the vinegar. And I'm going to highlight the other chemical now separately. It says 30.5 centimeters cubed of a solution of sodium hydroxide. So the green volume is with the green chemical. 30.5 is with sodium hydroxide, 25 is with vinegar. So you've got to read this and watch the order that they're spoken to you in English with a concentration of 0.5. So the 0.5 is for the sodium hydroxide. because that's where it is in the sentence. It's obviously talking about the sodium hydroxide, so I'm going to color code that green. All right, now what we got to do is organize that information. And I always advise my students to rewrite out this balanced equation. They will always give you a balanced equation, and you've got to rewrite it out and get the information in the right order. So what I'm going to ask you to do is I'm going to ask you to pause the video and rewrite out this chemical reaction now. Pause the video and do that now, okay? Okay. Okay, so this is what you should have done. Hopefully you did the same thing as me. We've got CH3, COOH, that's what we were given, plus NaOH, react to give CH3, COOH, sorry, COONA, plus H2O. And what we're always interested in a titration is how does this react with this? So we're looking at the relationship between the two reactants. All right. The first thing we're going to do is we're going to try and write down the volume and the concentration for each one of these. So I do this by putting two arrows here and here. One is for volume, one is for concentration. And I strongly suggest to you that at this stage, you write the volume in liters and the concentration in molar for each one. So if you've been given it in centimeters cubed, convert to liters now. And if you've been given it, yeah, that's basically it, okay? If you and if, by the way, at this stage, we know the concentration of one of these and we don't know the concentration of the other one. So whichever one is the unknown concentration, you should leave it as a question mark, okay? So one of these should have a number, so it should be maybe just, for example, 0.5 molar, and one should be question mark molar, okay? And then both of these, you should have the volume that was used in liters. So what I'm going to do is I'm going to go ahead and I'm going to scroll back over here so you can read the text. All this information will be up here somewhere. Just make sure you put it with the right one in the equation. So I'm going to pause, get you to pause the video and write down, add them to the equation now. Pause the video, do that now. Okay, all right, so this is what we should have done, okay? The acid in the text, it told us that we used 25 centimeters cubed of vinegar was being used to neutralize this many centimeters cubed of the sodium hydroxide. So we do know the volume of vinegar that was used, and that would go here. Now it said 25 centimeters cubed, and I want to know how many liters is that, okay? Now most of you should know how to do that conversion, but I'm going to show you. If you've got 25 centimeters cubed, you're going to multiply that by a conversion factor that converts centimeters cubed to liters, okay? So you set up a fraction, and we're going between centimeters cubed and liters. And what we want to do is we want these to cancel out centimeters cubed and leave us with liters in our answer, okay? So what we're going to do is make sure centimeters cubed is on the bottom here, so they can cancel with centimeters cubed, and liters is on the top. And what's the relationship between centimeters cubed and liter? Well, the answer there is that for every 1 liter, there are 1,000 centimeters cubed. So now we have a sum to do. We've got 25 centimeters cubed, so I'm going to do 25 times by fraction button, 1 over 1,000. And that's going to give me 0.025 liters, 0.025. So at this stage, we're putting in 0.025 liters. I'm going back to find out if I know the molarity of the dilute, of the vinegar. Now I'm looking through there and I don't see any number that goes with molarity or moles per liter or concentration of the vinegar. And if I look down here to the next part, part C, that's what I'm being asked to find, calculate the concentration of ethanolic acid. So that must be my unknown. I do not know this. So this is going to be a question mark amount of molar. Right, let's look at NaOH now. All right, so again, what you should be doing is you're looking for the molarity, the moles per liter, and you're looking for the volume in liters. Now, if you didn't convert to liters, I've shown you how to do liters of CH3COOH now, so you should be able to do liters of NaOH. So again, I'm going to pause the video. You can see where I've done that calculation. Pause the video and do that if you weren't able to do it before. Okay, so the information that we should have here now is that the NaOH we use 30.5 times by 1/1000, which is going to give me 0.0305. So I use 0.0305 liters, and the concentration from the question, it told me it was 0.5 molar, 0.5 moles per liter. 0.5. All right. Now, what I'm about to do is I'm about to just get rid of this out of here because it's kind of in my way. And we're going to label these two things. One of them is known and one of them is unknown. One on the left here, CH3COOH, this is what we call our unknown. And the reason it's unknown is we know the volume, but we don't know the concentration. And this is what we're going to be trying to find. This one is known because we know both the concentration and the volume. And this will, every titration will always be like this. You will have one known and one unknown. The last thing to think about is from the equation here, what is the reacting ratio? Now I can see in this case, actually, do you know what? If you know what I'm talking about, which you should if you've done a couple of these before, you're going to go ahead and pause the video and write down the reactant ratio. Do it up here. Okay. Pause the video, do that now. Right, so most of you, if you've done stoichiometry before, you know how reactions work. We're looking for coefficient numbers, which are numbers in front of the balanced chemicals in the equation. Now, because there are no numbers, that means that these are all ones. And what this means is that we react 1 part CH3COOH with every 1 part NaOH. So they react in an equal ratio, 1 to 1. And that is relating to the number of moles that are reacted. Very good. All right, let's go back to part C now. This is when we actually get into the meat of the question. It says calculate the concentration of ethanoic acid in the diluted vinegar. So we're working with the diluted vinegar, which is just using the numbers in the titrate in the text here, because this is what we were using, 25 centimeters cubed of the dilute vinegar. So what we want to find is this guy here. That's what we're expected to find in this part of the question. So what I'm going to do is I'm going to go ahead and we're going to keep it. We're going to keep it all labeled up. So this is part C, and we're asked to find the concentration. Okay, so the first thing we got to do is we got to work with the thing that we know, which is this. And what we got to do is find out how many moles of this we have. We have a 0.5 mole per liter solution, and we use 0.0305 liters. How many moles did we use? That's what we want to find out. So we need to go from moles per liter to moles. Okay, so let's do that. We've got 0.5 molar, which is 0.5 moles per liter. So I'm going to write that down. Watch, 0.5 moles per 1 liter. And this is moles of NaOH. So literally just writing down what you know. This is the nice thing about doing it this way, rather than messing with formulas and stuff like that, where everyone gets confused. What am I talking about here? What am I talking about there? Just writing down what you know. I know the solution is 0.5 moles of NaOH per 1 liter. And what I want to know is how many moles did I use? So I'm going to times it by something, actually by something, which is going to go here, which will help me figure out how many moles I used, moles of NaOH. Now, what I obviously need to get rid of here is liters. If I want to go from moles per liter to moles, I need to get rid of liters. So if I put liters over here and I multiply a denominator liters by a numerator liters, then I can cancel out the liters. Watch, cancel out like that. Okay, so what now I want to know is how many liters did I use? Well, it was this guy here, 0.0305. So go ahead, stick that in your calculator, and that'll give you the number of moles that was used. Okay, and the answer I'm getting is 0.01525 moles of NaOH. So that's how much NaOH I used in the titration when I had these two numbers. Okay, the next thing we're going to look at is the ratio here. Okay, so when I was using this many moles of NaOH, how many moles of CH3COOH I got? Well, as you can see, it's a 1-to-1 ratio. So it means I used the same number of moles of CH3COOH. Okay, so therefore, I used 0.01525 moles of CH3COOH. COOH. Okay, because it's a 1-to-1 ratio. Now, if it was a 1-to-2 ratio, we'd have to add another step of calculation there. If it was a 1-to-3 ratio, but because it's 1-to-1, however many moles of NaOH you had, give the same number of moles of CH3COOH. I'm going to go on to the second line here just to keep it a bit cleaner. The next thing we want to find out, well, what was the concentration? We know how many moles, we know how many liters, so we can find out the concentration here. So what we're simply going to do is we're going to say we had 0.15, sorry, there's a 0 there, don't miss that, 0.01525 moles of CH3COOH, and I want to know molar, which is moles per liter. So if I've got moles here, to make it moles per liter, I need to put liters on the bottom. Okay, so moles per liter. Now, how many liters did I use? I've worked that out up here. It's 0.025, 0.025 liters. So go ahead, stick that in your calculator. So 0.01525 divided by 0.025, and that's given me 0.61 molar. And that makes sense. It's pretty close to this 0.5 and 0.61 molar CH3COOH. Now, if that was wildly way off, some crazy amount of molar, or yeah, then you might say, okay, that doesn't seem right. I need to have another look at it. All right, but that seems pretty good to me. So we found the concentration of the, and remember, and then that this is the dilute vinegar. This is the one we were talking about in the question. That's part C done, okay? Nothing to be too afraid of there, I don't think. The next thing we're going to look at is part D. We're going to look at part D and we're going to see what it does it ask us to do. So part D says calculate the concentration of the original vinegar. Now there's a hint there for my students to look back in the booklet to find the effect of dilution. There's a number of ways you can do this. You may have a way that works better for you than the way I'm going to show you, but I simply use a formula here, a formula that shows you the effect of dilution. Okay, so dilution means you have a concentration and a volume before and a concentration and a volume after because you're diluting. So we're going to call this M1V1. Okay, and this is the concentration before and the volume before you dilute. And then we're going to have M2V2. And this is the concentration after and the volume after you dilute. Okay, so what do we know? Let's think about what we know. All right, so we're going to plug in. We're going to say that this is the dilute and this is the concentrated. Okay, well, we know stuff about the dilute now. Okay, we know that the dilute is 0.61 molar. That's what we calculated here, 0.61 molar. Okay, times by the volume that we made when we concentrated it. Okay, so when we diluted it. So let's go back up here and find out. Okay, remember the dilute was 250 and the concentrated was 225 centimeters cubed. Okay, this is the conc and this is the dilute. Okay, now I'm going to do that in liters. So volume of 250 centimeters cubed in, sorry, it's just bounced a bit there now for a second. Actually, you know what? Let's just leave it in centimeters cubed. Should be fine. So this is 250 was the volume of the dilute solution. And now let's think about the concentrated. What we don't know the concentration of this, so that's our question mark. We don't know the concentration, but we do know the volume. We know we use 25 centimeters cubed of this. So with 25 centimeters cubed, do you know what? I'm actually going to leave this as M1 instead of a question mark. M1 with 25 centimeters cubed of the concentrated. We know the dilute is 0.61 molar because we just calculated that. And we know that when we made it up to 250. That was the volume. Okay, so now we want to get M1 on its own to isolate it. I've shown you how to do this before. Okay, what we want to do is divide this side by 25. Okay, because this is M1 times 25. You divide that side by 25, you can cancel them out and leave your M1, but you've also got to do the same on the other side because this is an equal sign. So we're going to divide this side by 25 as well. Okay, rewriting this, we're going to get M1 equals 0.61 times by 250 divided by 25. Go ahead, stick that in your calculator now, and we should get M1 equals. Okay, so I'm going to do this with you. Again, pause the video and have a go at doing this sum now. 0.61 times by 250 all over 25. And what I'm getting is 6.1 molar. Now let's logically think about that and see, does it make sense? Okay. Well, think about which should be more concentrated, the concentrated or the dilute? Think about that for a second. Obviously, the concentrated should be more concentrated, okay? So this one, 6.1 molar, the concentrated should be higher than the dilute. And obviously 6.1 molar is more concentrated than 0.61 molar. And you can see actually the relationship there is 10 times bigger. And we diluted it 10 times. So again, we're using logic, we're working it out. That makes sense. The last bit then says we've got an extra step to do here. And most of these titration calculations will have something like this, especially at higher level. It says the concentration of ethanolic acid in a different vinegar bottle, so scrap all the old numbers, this is a new set of numbers, was 0.8 moles per liter. Okay, it says calculate the mass in grams of ethanolic acid in 250 centimeters cubed of this solution. So it's 0.8 moles per liter. We don't have a liter, we have 250 cm cubed, and we need to calculate the mass in grams of ethanolic acid. Okay, so I'm going to do this one here, just underneath, just keep it handy. All right. Let's step through what we know. We know we've got 0.8 moles per liter. Sometimes it's a good idea to just actually start by writing down what you know. We know we've got 0.8 moles per 1 liter. That's what we know. And we want to find out how many grams is this. Now, again, we can't jump straight into grams because there's no grams here yet. So the first thing we've got to do is maybe find the moles and then find the grams. Okay. So what can we multiply this by in the numerator here to give us moles in our answer? Okay, so I want you to pause the video and have a go at using what we have in the question here to go from moles per liter to moles over here. What do we got to do? Pause the video, write it down. Okay, so I'm hoping that you've seen that if we multiply by liters here, they will cancel out and leave us moles. So where in the question do we have liters? Well, we don't, but we do have centimeters cubed. So let's convert this to liters first and then put it in and we'll get moles. If you weren't already ahead of me doing that, pause the video, do that now. Okay, so it's a little bit of rough work here. If you weren't sure, 250 centimeters cubed times by, and we want to convert from centimeters cubed to liters. Centimeters cubed should cancel with centimeters cubed and leave us liters. 1 liter for every 1,000 cm cubed, and you should get 0.25 liters. Okay, so this here is 0.25 liters. Go ahead, stick that in the calculator, and we should get a number of moles in our answer. What you should have got here is 0.2 moles. Okay, so we have 0.2 moles when we use a quarter or 0.25 liters. We get 0.2 moles of ethanolic acid. All right, the next thing we got to do is go from moles to grams of ethanolic acid. All right, so we want our answer over here to be in grams. How can I go from moles to grams? Well, again, I've got to use a conversion factor that goes between grams and moles. Okay, so how exactly am I going to do this? All right, so I want you to pause the video and write down what should be on the top and bottom of this conversion fraction. Pause the video, do that now. All right, I'm hoping that you see that we got to put moles on the bottom here and they cancel out with those moles, and we've got to put grams here. All right, the relationship for this substance, ethanolic acid, is for every 1 mole, how many grams do I have? Well, of course, that depends on the masses of all the atoms. So you guys should know how to do this. We've done this loads of times before. How do we work out the molar mass, 1 mole's mass of CH3COOH? Pause the video, do that now. Okay, so what I have here from my periodic table, I have 2 carbons. So each of those is 12 grams, so 12 by 2. Plus I have 4 hydrogens. So that's 4 by 1. Plus I have 2 oxygens. Getting a bit messy there. Plus 2 by 16. Okay, each oxygen 16. If you add them all up, you'll get 60. So if you were using 60 grams per 1 mole, well done. Okay, and then you put that in your calculator and we should get grams. So we got 0.2 times by 60 over 1. And you get 12 grams. Okay, so the answer to E would be 12 grams in 250 centimeters cubed. All right, so well done if you got that right. These questions are usually pretty straightforward, as in they're all very similar. The numbers change, but the techniques and the way of really thinking them through shouldn't change that much. Some of the titrations later on have little extra bits in them that we have to deal with, but this is a pretty standard base to work off. Again, you won't learn this by just doing this one and going, I know that, brilliant. You have got to now take that, what we've just done, and go and practice loads of other ones. You know where to find them. You'll find them on study clicks. You'll find them in your exam papers. You'll find them in the book. You'll find them in my booklet if you're in my class. Practice them until your logic is brilliant and you're able to think them through and do them all. Okay. All right, guys, that's it. I hope you found that helpful. And I will see you in a future video.